Hey, this is KZORET Ryan in Midtown. Today I'm going to show you a little bit about how the multipath works and the reflections that you get with microwave. So I've got this 31 dB dish. I'm about 0.7 miles away from the cell site, and I'm actually oriented right now about 15 or 30 degrees to the right of what the cell site is. And it's a bit difficult to see because of the light, so let me just cover it up real quick. You can kind of see there that we've got 2 bars, so that's probably about -80 or so, and I'm actually peaking up to 3 bars there, and that means I'm getting somewhere around -75 most likely. When I point this most directly towards where the cell site is, which I know it's nighttime, so it's not very helpful, but you can see the street light, and the cell site's right about that direction. So when I point this towards the cell, and I get the elevation right, because right now it's pointed very much up in the air, I actually don't have line of sight. And you can see I'm only getting 1 indicator bar, so I just barely have a link, and that's it. When I twist this up, which is going to point towards some trees, you can see the outline of the trees. When I point it up into the trees, what's going to happen is the signal will actually bounce in the trees, and intermittently I'll get a stronger signal. So here, let me raise it up just a little bit more, and there we go. My dish, this is the angle of the dish right now. I am 0.7 miles away, and this is pointed way up in the air, but I'm getting intermittently 2 bars of signal. So what's happening is the signal's going up into these trees, and it's actually reflecting off of the branches of the trees. A really extreme example of this is if I were to turn the dish around the entire opposite direction. It's going to be a good 90 degrees opposite the direction of the cell site, and you can just barely make out the outline of a building that's right there. That is the Sears Crosstown building. And what we can actually do is point the dish into that building, and my signal is going to reflect off of that and make it back to the cell site. So pointed off in that direction, I'm still maintaining 1 bar of signal, and just to make it obvious that this is not some sort of hoax, let me twist it a little bit more, and now I'm just pointed down the street, and the signal should die off. It takes a little bit of time for the LED indicator to actually get caught up, but there, you can see that we've lost signal. So now I'm going to aim it into this building, into that Sears Crosstown building. Let me give it some up tilt to get actually over towards there. And now here in a second we should see that the link comes back up. To fine tune it, of course. We're using this as a passive reflector right now, basically shooting into this big vacant building. It's about 1.5 million square feet, and eventually some signals getting back out to the cell site and vice versa. So with that, we're able to get a link. Now, it's not a fantastic link. We're only getting 1 bar, so most likely this wouldn't even pass any traffic. But if I were to continue to play with this, most likely I could get to the point where I have 2 bars of signal or so. Nonetheless, this is kind of giving you an idea as to what it's like playing with microwave, how frequently you'll get these multipath or passive reflector situations. And so even in situations where you don't expect to have line of sight to a cell, you do stand a slim chance of being able to point it in almost a seemingly arbitrary direction and getting some sort of signal. So this is KZORET, and I hope you found this video helpful.